So on my screen is the most recent Cape Pure Math exam. It's dated June 21st, but actually the exam was done yesterday, July 12th. So we're going to take our time and go through the solutions for this paper, beginning with question 1. Part A is a truth table. We're asked to complete the truth table. P and Q are the propositions. So let us complete the third column, which is not P. Not P is just the opposite of P. And notice for P, we have true, true, false, false. So not P is the opposite, which is false, false, true, true. And not Q is the opposite of Q. And so it's false, true, false, true. PRQ, the symbol is PRQ. So PRQ, only time it's false is when both of them are false, right? So PRQ, so this is true. We're combining the first two columns using the R conjunction. So it's true, and if both statements are false, then the compound statement is false. Not PRQ will be the opposite of this column. That's the fifth column. So this is the PRQ column. So not PRQ will be the opposite of not PRQ, which is opposite of this column here, which would be false, 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 true. Not PRQ, we're combining the third and the fourth column, since these columns have not PRQ, not P and not Q respectively. So we're combining these statements using the R conjunction. So notice both statements are false, so the result is false, and then everything else should be true. Hence, state whether the statements not PRQ and so this column, not P, not PRQ, which is this column, and this column, not P or not Q, state whether they are logically equivalent. So two statements are logically equivalent if the truth values are the same. Notice the truth values are not the same. This false, false, and false, true, false, true. So these are not the same truth values. So the statements, so not logically equivalent, since the truth values are not the same. Alright, truth values are not the same. So in other words, they are different. So these two statements, they are not logically equivalent. Let's move on. So next, we're asked to write the converse of the statement. If n is an integer, then n squared is an integer. So the converse of a statement is simple. We switch the hypothesis and the conclusion. So we're saying that the converse would be if n squared is an integer. So we put the conclusion at the front. If n squared is an integer, then n is an integer. That's the converse. So we simply switch around the two statements. Next, for two real numbers x and y, the binary operation is given by, and the operation is there, asterisk, is given by x by y is x squared plus y squared. Prove that the operation is closed in the set of real numbers, which is what R, so R stands for real numbers. Okay? So we just about writing a statement. If x is a real number, or if x belongs to a set of real number, then x squared also belongs to a set of real numbers. So if you have a real number, you square that number, then you will result in a real number. Also, if y belongs to a set of real numbers, as we are told, then y square belongs to a set of real number also. So any real number, it's squared, you'll end up with another real number. So x squared is a real number, y squared also belongs to a set of real number. Then it means therefore that x squared plus y squared belongs to a set of real numbers. So hence the operation is closed. Meaning any operation with whatever the values of x and y are, then you'll end up with a real number. Next, we're asked to determine whether or not the operation is commutative. Now, just remind ourselves here, there's an operation. So, if commutative, then x asterisk y is equal to y asterisk x there. Good. Now let's work out the left hand side. Now, as we are told, that is equal to x squared plus y squared at the top of the question, which means also y asterisk x is equal to y squared plus x squared. Now, since x squared plus y squared is equal to y squared plus x squared, then the operation there is commutative. In other words, the order is not important. Commutative, right? So for example, 2 asterisk 5 is the same as 5 asterisk 2. That's a basic example. Alright. Part C, the function f of x, ax cubed plus 3x squared minus b, is divisible by x minus 1 and has a remainder of minus 5 when divided by x plus 2. So if divisible by 2x minus 1, it means that 2x minus 1, of course, is a factor. So we can equate it to 0, and if substitute 2x equal to 1, which means that divide both sides by 2, x equal to a half. So it means therefore that's f of half, or if you prefer to use 0.5, is equal to 0, since 2x minus 1 is a factor. And a remainder of minus 5 when divided by x plus 2, if you solve for x plus 2, if you equate x plus 2 equal to 0 and solve, you end up with x equal to minus 2. So f of minus 2 would give you a remainder of minus 5. So let's make these substitutions now and see if we can find the values of a and b. Now, f of half, so here's a function. We're going to replace x with half, so it's a times half cube plus 3 times half square minus b, and we are told that's equal to 0. Let me call this equation 1. Equation 2, f of minus 2, so it's a. We're replacing x now with minus 2, so it's minus 2 all cube plus 3 times minus 2 all square minus b, we are told is equal to minus 5. Sorry, so it should be minus 5. Okay, let's see if we can simplify both equations. So equation 1, half cube, that's 1/8, so it's a times 1/8, that's 1/8a. 3 times, no, half square is at a quarter, so 3 times that, that's 3/4. 3/4 minus b is equal to 0. Let me just separate this. Simplify the other one, minus 2 to the power of 3, that's minus 8, so minus 8a. Plus well, minus 2 squared, that's 4. Right, so 4 times 3, that's 12. So positive 12 minus b is equal to minus 5. So we can solve this simultaneously. So I guess we can subtract. Now let's subtract. So equation. So subtract what is above. So term above minus term below. So it's 1/8a minus 8a. That's 8 and 1, positive 8 and 1/8a, right? Term above, take away term below. So it's 3/4 minus 12. That should give us what now? Negative 11 1/4. And then minus b. Minus b becomes minus b plus b. You end up 0. That's why we subtract in the first place. And over here, the right hand side, 0 minus 5. That's positive 5. So now we can solve for a. So 8 and 1/8a equal to, bring over that, we have 5 plus 11 1/4. So 8 and 1/8a is equal to 16 1/4. So to find the value of a, we can divide both sides by 8 and 1/8, right? I'll just use my calculator for that. So 8 and 1/8 cancel itself. So we end up with a equals 16 1/4 divided by 8 and 1/8. We end up with 2. Or if you prefer, you work in this question, you could use decimals if that you prefer. Now to get the value of a, we can, let me just substitute a equal to into, let me use equation. Which equation should I use now? It doesn't matter which equation I use. Let me use equation 1. Or equation, let me call this equation 3. And let me call this equation 4. So let me use equation 3. Into equation 3. So in equation 3, I'm going to replace a with 2. So here's equation 3. Let me do it over here, replacing, here's it. Replacing a with 2. So 1/8 times, so is 1/8 times 2 plus 3/4 minus b equal to 0. I'm solving for b now. So 1/8 times 2, that's 2/8, that's 1/4. Plus 3/4. I can add b to both sides. I group the b over here, so positive b. So 1/4 plus 3/4, that's 1. So b is equal to 1. So our solution, b is equal to 1 and a is equal to 2. Now we move on to one smallest base, which is base 2. So the first term, that's okay, that's log x base 2. The second term, we want to make it base 2, so we simply just change it to base 2. But remember, the original base was not 2, it was 4. So we divide by log same base 2. So log, we'll put the whole base here, which is 4, base 2 there. Plus, again, we change the base from base 16 to base 2. But of course, we have to divide by log the whole base times base 2, which is the base we want, equal to 7. Let's see if we can simplify each term. Now, the first term is okay, log x base 2, plus the second term, log x base 2. The denominator now, to get the value of a denominator, you think of which value, what power can you raise a base to get 4, and that's 2. 2 to the power of 2 will give you 4. Third term on the right hand side here. To get the value of log 16 base 2, you think of which value can you raise a base to get 16, and 2 to which power give you 16 now? 2 to the power of 4, so this will be 4. Equal to 7. So we end up with log x base 2. Now, here's where the crux of the matter lies. What is the coefficient of the log here? The coefficient here is half. It's 2, so 1 over 2, half. So we can rewrite, what's a rule in log here, the half, the coefficient, we can make it the power. So it's x to the power of half. And notice for this third term on the right hand side here, the coefficient is a quarter, because 1 in front of the log, a quarter. We can erase the x to the coefficient, that power there is one of the laws of logarithms, alright, equal to 7. That's a very important step, rewriting where you put the coefficients of the log and bring them to the index there for the x. Alright? So now, law of logarithm again, we can group all the terms. So log, since we're adding log base 2, and we can simply multiply all the terms. So it's x times x to the power of half times x to the power of a quarter. So we combine all the logs. Alright? That's another rule in logarithm. Since it's plus, we multiply. When it's division, we normally subtract, right? And all of this is equal to 7. If we see if we can simplify all the terms in the bracket, the law of indices there, so it's x to the power of 1 times x to the power of half times x to the power of a quarter. That's x to which power? What's 1 plus half plus a quarter? That's 1 3/4 or 7 over 4, right? Since 1 is 4 over 4, half is 2 over 4, 1 over 4, so we end up with 7 over 4, and that's equal to 7. Now, another rule of logarithm, whatever is in the bracket, x to the power of 7 over 4, whatever is in the bracket is equal to 2 to the power of 7. So the base raised to the power is equal to x is equal to whatever is in the bracket. Now we're solving for x, so we can raise each term to the power, the reciprocal of the power x power there. So x to the 7 over 4. We're going to raise this to the power 4 over 7. And the other side, we're going to raise it to the power of same power, 4 over 7. Alright, now any value times this reciprocal, you end up with 1. So this is x to the power of 1, 7 over 4 times 4 over 7. And we're taking it, remember this line in indices, x to the power of a, all to the power of b is equal to x. So we take the product, ab. Alright, simply just multiply the two powers. Likewise, 7 times 4 over 7, we end up with 4. 7 times 4 over 7, that's 4, right? So x equal 2 to the power of 4. And what is 2 to the power of 4? 16, so x is equal to 16, and that's our solution. Question 2. The diagram below shows a graph. F of x is x squared plus 2. On the domain, x is greater than 0. So notice it's on the positive side of the x-axis. Let us see what they're asking us to do now. Sketch the inverse of f. So the inverse of a function, to get the inverse of a function, you can simply reflect that function in the line y equal to x. Now the line y equal to x would look something like this, right? The line y equal to x, you really should be using a ruler, but so the line y equal to x, this is the line y equal to x. So to get the graph of the function there, we simply just reflect this line into the line y equal to x. Now, what's special about reflecting a point in the line y equal to x? The coordinate switch position. So if you'll notice, this coordinate here is 0, 2. Since you count, this is 2, 0, 2. So it will reflect in the 2, 0. So let's do the point. Alright, let me see if I can reflect another point. So to get the inverse, you simply draw in such a way, so there is symmetry. Alright, so there is symmetry. So the y line y equal x should be like a mirror line. So this is the original function, and the inverse is like a reflection in the line y equal to x. Alright, so the line y equal x basically should be a symmetrical line between f and its inverse. Let's see what else they're asking us. Show that the inverse of f is a function. Now here's the inverse of f. Now how do we show that a graph is a function? To show that a graph is a function, we do what we call a vertical line test, is one of the ways. So you can just write a statement, any vertical line drawn will cut f inverse only once. Notice the shape of f inverse. So in other words, any vertical line drawn, there's a statement, just write a statement, any vertical line drawn will cut the inverse of f only once. We call it the vertical line test. Hence, f inverse is a function. And while I'm at that, let's just show you an example of a graph that will not be a function. So, for example, if you have a graph like this, with a shape like that, then this will not be, is not a function, because if you draw a vertical line, notice it cut the curve only once. It cut the curve twice. So this is an example. This is not a function. Alright? Not a function because this fails a vertical line test. A line drawn, vertical line drawn will cut this twice. While here, this graph we're looking at f inverse, the graph in question, in a vertical line drawn, if it's obvious, definitely cut f inverse only once. So next we're asked to prove that f is one-to-one or injective. So we can let f of a equal to f of b, and if it's injective or if it's one-to-one, then a should be equal to b. Now let's remind ourselves of what f of x was. F of x was x squared plus 2, which means that f of a would be replacing x with a squared plus 2, and to find f of b, replace x with b, which will be b squared plus 2. So we can subtract 2 from both sides. We end up with a squared equal to b squared. And if we take the square root of both sides, then a is definitely equal to b. Because remember, we're told that x is greater than 0. So the negative values are not a possibility. So definitely positive values, because at the top of the question, let me just remind you, the question has given us some information that x is greater than 0. So we're talking about just the positive values for x, right? So a is equal to b. Alright, since both a and b has to be positive or greater than 0. So hence f is injective. So next we're asked to determine whether or not f is onto, or the other term we use for onto is surjective. No, it's surjective. It's difficult to say. Let's just check the graph again. It's difficult to say whether or not the function is surjective, because for this function, let me just go back to the definition for the function. Notice the domain was given, x greater than 0, but the codomain was not given. We weren't given, the f of x was not defined in terms of if it's set of all real numbers or greater than 0. Now if we make the assumption x greater than 0 and y greater than 0, then the answer would be yes, the function is surjective. And furthermore, we are able to find the inverse for the domain, so of course the function is onto. But as it is now, it's impossible to say, because notice the codomain was not given. So I'll put here no conclusion can be drawn or can be made, since the codomain, and by codomain we talk about the possible set of y values, codomain was not given. Now, if the codomain was the same as the domain, no matter the domain was x greater than 0, if the codomain was the same, then yes, we could say the function is onto or surjective, and if the codomain was y is a member of R, meaning y could be negative numbers, then it would not be onto. But if this was the case, it would be onto. If this was the case, it would not be onto. So okay. So here it would be onto, since there's an inverse. And any horizontal line drawn would cut the graph at least once. And here it would not be onto. But inconclusive, since no codomain was given. Next, we're asked to solve equation, the modulus equation here. So the modulus of x squared minus 4 is equal to 3x minus y, meaning that x squared minus 4 could either be positive 3x plus 2, 3x minus 2, sorry, or x squared minus 4 could be minus 3x minus 2. So let's solve each equation separately. The first one, we can group the quadratic, so we have x squared. Group the 3x, we have minus 3x. And group the constants, we have minus 4 plus 2 equal to 0. Let's focus on this one. So x squared minus 3x. Now negative 4 plus 2, that's minus 2 equal to 0. I'm going to factorize. We can rewrite the minus 3. So we think of which two numbers add to give minus 3 and multiply to give minus 2. So this one seems like it cannot be factorized. So we have no option but to use the quadratic formula. Let's use the formula here. So x is minus b plus or minus square root b squared minus 4ac all over 2a. Notice the a value is 1, the b value is minus 3, the c value is minus 2. So we can make our substitutions. So x equal to minus 3, that's positive 3, since b is negative 3. Square root. Now b is minus 3, so b square will be 9. A, what's the value of a? The value of a is 1, and the value of c is minus 2. So it's minus 4 times 1 times minus 2. That's positive 8. All upon 2a. 2a is 1, so 2 times 2. So x is equal to 3 plus or minus the square root of 17 upon 2. So which means that the solution x is equal to 3 plus 17 plus root 17 upon 2, or x equal to 3 minus root 17 upon 2. And I'll leave it in that form. Let's go to the other over here now. So this is x squared minus 4 equal to minus 3x plus 2. Right? So grouping, so we have x squared plus 3x. And then we have minus 4 minus 2, right? So we have with x squared plus 3x minus 6 equal to 0. Again, I don't think this can be factorized. So using the same formula, and this time now a is 1, b is 3, c is minus 6, so make our substitution. Minus b, that's minus 3. Plus or minus the square root of b squared, which is 9. Minus 4 times a times c, so minus 4 times 1, which is 4 times minus 6, that's positive 24. Upon 2a, a is 1, so 2 ones 2. So x is equal to minus 3 plus or minus the square root of, what's 9 and 24? 30. Is that 33? 33. Upon 2. So we can separate. So hence x is equal to minus 3 plus root 33 upon 2, or x equal minus 3 minus root 33 divided by 2. So let's use a calculator to work out these values now. So 3 plus root 17 divided by 2, that's equal to, let me use 2 decimal places. Now I pause the video to do the calculations. So 3 plus root 17 divided by 2, that's 3.56. And 3 minus root 17 divided by 2, that's negative 0.56. And over here, 1.37. And over here, I didn't work out the value. It's actually a negative value. Let me just work it out. Now, so notice we end up with 4 values. But which solutions do we take? We'll take the 3.56 as one solution. And we'll also take 1.37 as the other solution. So x equal to 3.56 or x equal to 1.37. Now, why these values? Sometimes these can be just a little bit tricky. You have to look what you always have to try the values. Notice this was the equation. So you'll try the values. And if the 4 values were calculated, only these 2 values would work. Which 2 values we're talking about? 3.56 and 1.37. The one with the negative values will not work. Just the positive. Next, given that alpha, beta, gamma are the roots of the equation 2x cubed. Now notice 2x cubed, this is the a. The b is the coefficient of the x squared, and that's minus 1x squared c, and these negative 1. And these are the roots. Now let's focus on the cubic equation here. Now we know that the sum of the roots, let's deal with the first section here, alpha, beta, gamma. The sum of the roots, alpha plus beta plus gamma, the sum of the roots is negative b over a. The sum of the roots is given by negative b over a. In this case, negative b, notice b is negative 1, because negative 1x squared. So let's write them out here. A is 2, b is negative 1, c is 3, d is also negative 1. So negative b will be positive 1. So positive 1 over a, which is 2. The sum of the product, so alpha beta plus beta gamma plus gamma alpha, that's equal to c over a, which is what c over a? C over a, that's 3 over 2. Since c is 3, a is 2. And the product of the roots, that's alpha times beta times gamma, is minus d over a. And minus d, d is minus 1, so minus d over 1. Notice all the denominators are a. Alright, so we have those 3 equations. Yeah. Now, the cubic equation. The cubic equation whose roots are 1 over alpha, 1 over beta, and 1 over gamma is given as, and is a standard, is given as, so it's given as x cubed minus the sum of the roots, and the sum, and these are the roots, so the sum will be 1 over alpha plus 1 over beta plus 1 over gamma times x squared plus the sum of the products, and these were 1 over alpha times 1 over beta plus 1 over beta times 1 over gamma plus 1 over alpha times 1 over gamma x minus the constant minus a constant, which would be the product of these three roots, which is 1 over alpha times 1 over beta times 1 over gamma. And all of that must be equal to 0. So let's work out the coefficients now. 1 over alpha, 1 over beta, 1 over gamma. Let's work that out. And notice before we work that out, in the first bracket we have the sum of the roots. Notice we have the sum of the products, and notice we have the product of the three roots as a constant. So let's work out now. Let's work out the constant first. Let me start from right. Work out the constants first. 1 over alpha times 1 over beta times 1 over gamma. Alright. Now, we know that, let me just go back to the top of the question. We found that earlier that the product alpha beta times gamma is equal to half. We know that recall alpha beta times gamma was equal to a half. If we reciprocate both sides, it means that alpha beta times gamma is equal to 2 over 1, which is 2. Alright, so we can reciprocate both sides and get that. Now let's work out the next one, which is, let's look at the first one, 1 over alpha. So now we can reciprocate both sides. This is equal to 2, right? So alpha beta gamma is equal to half, or 1 over 2. Reciprocate both sides. Then 1 over alpha beta gamma is equal to 2 over 1. So this value is going to be 2. Alright, just erase it for now. Just bear that in mind. Now let's work out the first bracket. 1 over alpha plus 1 over beta plus 1 over gamma. I'm going to bring everything in one common denominator, which would be alpha beta gamma, one common denominator, which means that for this denominator to be alpha beta gamma, I will multiply the top by beta gamma. Equivalent fractions, beta gamma. For this denominator to be alpha beta gamma, I'd have to multiply top and bottom by alpha gamma. So the top here also by alpha gamma. So I end up with alpha gamma. And then the final fraction, for it to be the same as this, we'll have to multiply by alpha beta. So we'll also have to multiply top by alpha beta. So this term would be alpha beta. Now we have all the values. Let's remind ourselves of what the product was. The product was equal to a half. We have it here. The product was equal to a half, or 0.5. So the denominator here will be 0.5. The sum of the products would have been, let me just double check. The sum of the product we found to be 3 over 2. Alright, so it's 3 over 2 divided by 0.5. Or 3 over 2 is same as 1.5, right? So 1.5 divided by 0.5, we end up with positive 3. Now we also need to calculate now the second bracket. I'm out of space. Where can I put it? I'm going to have to erase some stuff. Let me put it over here. The second, which is 1 over alpha beta. 1 over alpha times 1 over beta plus 1 over beta times 1 over gamma plus 1 over alpha times 1 over gamma. So we need a common denominator. The common denominator would be the same as over here, alpha beta gamma. Now for this denominator to be alpha beta gamma, you'd have to multiply the denominator by gamma, which means that you'll have to multiply numerator by gamma also, so this will be gamma, plus, for this the second fraction, for the denominator to be alpha, beta, gamma, you need to multiply by alpha, so multiply numerator by alpha also, equivalent fraction, so that's alpha, plus, and the final fraction, you have to multiply denominator by beta to get it to be the same as the others, which means you have to multiply numerator also by beta for the fraction to remain equivalent, so that's beta. Now, notice on the top is the sum of the roots, which I already found. Let's check what the sum was again. The sum was for alpha, beta plus gamma, that was half, or 0.5. So numerator, that's 0.5 or half. Divide by, and remember what the value of alpha, beta, gamma was. The value of alpha times beta times gamma, we have it already here, was 0.5. So it's 0.5 divided by itself, which is equal to 1. So the second bracket would be equal to 1, and the first bracket would have been equal to 3. So this value would have been equal to 3, and this value would have been equal to 1, this value would have been equal to, so the solution, the cubic equation would have been x cubed minus 3x squared plus 1x minus 2. So the first bracket is 3, the second bracket is 1, and the final term, 1 over alpha times 1 over beta times 1 over gamma, we found that to be 2. So that's our solution. X cubed minus 3x squared plus x minus 2. Now we move to question 3. Express 4 sine theta plus 3 cos theta in the form r. And we have sine theta plus alpha. We expand that. That's sine theta, the addition rule. Sine theta cos alpha plus sine alpha cos theta. And of course, we can distribute the r to each term. So 4 sine theta plus 3 cos theta. And it's r times all of that. So it's r sine theta cos alpha plus r sine alpha cos theta. And now to get the values of r and theta, we can equate coefficients. Equate coefficients of cos theta and sine theta. Now let's do this. Notice the coefficient for cos theta on their left hand side is 3. And the coefficient for cos theta on the right hand side is r sine alpha. Notice the coefficient for sine theta on the left hand side is 4. And the coefficient for cos theta, for sine theta on the right hand side, notice what's besides the sine theta, r cos alpha. Now we can divide one equation by the other. So 3 divided by 4, we get 3/4. And r sine alpha divided by r cos alpha, r cancel r, and sine alpha divided by cos alpha, that's tan alpha. So tan alpha is equal to 3/4. Don't forget the 3, 4, 5 triangle. Draw a triangle here. This is alpha, tan alpha, opposite over adjacent, 3 over 4, so this would have to be 5. Alright, so that's tan alpha. We can use it to get r. So if tan alpha is 3/4, it means that sine alpha is equal to opposite. Sine is what? Opposite over hypotenuse. So sine alpha is 3 over 5. Opposite 3, hypotenuse 5. And we can use it to get r. We can substitute in this equation. So 3 equal r sine alpha. Let's use this equation. It doesn't matter which one I use. You could have found cos alpha and use the second equation, but I'm using the top one. So it's r times sine alpha, so it's r times 3 over 5. So solving this, we end up with, if I multiply both sides by 5, I will get what? 15 equal 3r. Divide both sides by 3. R is equal to 5. So we have r and we have alpha. So therefore, if we back remember what the question was, there's it again. So we can rewrite this expression in the form r sine theta plus alpha, which means that 4 sine theta plus 3 cos theta. Therefore, 4 sine theta plus 3 cos theta is equal to r, which is 5. And what is it? 4 sine theta plus 3 cos theta, r sine theta plus alpha. So r, which is 5 sine theta plus alpha. I didn't find alpha. Tan alpha was 3/4. So which means that alpha would be tan inverse 3/4. So alpha would be equal to, using a calculator, I'm using 1 decimal place, so it's 36.9 degrees. So theta plus alpha, so theta plus 36.9 degrees. Next, we're asked to solve this equation for theta is between 0 and 360 degrees. That's, remember, 360 degrees is equivalent to 2 pi radians. So 4 sine theta plus 3 cos theta. Remember, we just found out that 4 sine theta plus 3 cos theta was equal to, let's check it, double check. We just proved this was equal to 5 sine theta plus 36.9. So we can just replace it with 5 sine theta plus 36.9. So this is 5 sine theta plus 36.9 degrees, and that's equal to 2. We divide both sides by 5, which means that sine theta plus 36.9 is equal to 2/5, or so 0.4. So theta plus 36.9, what's in the bracket, all of this would be equal to sine inverse 0.4. Therefore, theta plus 36.9 is equal to, let's find the two angles. Sine inverse 0.4, 23.6 degrees using 1 decimal place. So it's 23.6 degrees. But note, remember, sine is also positive in the second quadrant. So to get the other angle, you'll subtract 23.6 from 180. You end up with 156.4. Alright, and then to get theta now, you'll add 36.9 to both sides. So theta is 23.6 plus 36.9, or theta equal 156.4 plus 36.9. So you add 36.9 to both sides. So theta would be 23.6 plus 36.9. So these are a solution. If you that cos A is 12 over 13, let me just draw a triangle here. There's what we call a 5, 12, 13 triangle. So let me call this angle A. Cos A, remember cos is adjacent over hypotenuse. So the adjacent is 12. The hypotenuse is 13. Using Pythagoras theorem, the side would have to be 5. Alright. That's A. Let's do C. Sin C. It seems an error was made on this paper. I don't see an angle B there. So sine C, so C, this should be the Kelsen A and B, but I imagine some error was made. This should be actually A and C, not A and B, right? So 5/13 sine C, so angle C, sine is opposite over hypotenuse. So opposite is 5, hypotenuse 13. Pythagoras theorem, this would be 12. The adjacent for this angle would be 12. Alright, we're asked to calculate cos A minus C. There's no angle B, so it must be error there. So cos A minus C is the expansion is cos A, cos C minus sine A, sine C. Now what is cos A? Cos A we are given 12/13. Cos A is 12/13. This was addition formula or subtraction formula. Cos C using this triangle. Remember cos C, cos is adjacent over hypotenuse, so cos C will be 12/13 also. Minus sine A, sine is opposite over hypotenuse, so sine A will be 5/13. And sine C would be opposite over hypotenuse again, 5/13 again. So therefore what we have here is 12 times 12, that's 144. 12 times 144 upon 13 times 13, 169. Minus 5 times 5, that's 25. Upon 13 times 13, 169. So our answer would be 144 minus 25. That's 119. Let's move on to the final section. Solve the equation cos theta is equal to sin theta minus pi/3. So cos theta is equal to, let's expand. So sin theta minus pi/3, let's expand addition formula. So sin theta times cos pi/3. And remember pi/3 radians, by the way, is equivalent to 60 degrees. Since you're using pi radians to be 180, so 180 divided by 3 is 60 degrees. Alright, so cos pi/3 is same as cos 60 degrees, since most of you keep your calculator in degree mode. Minus the expansion, so minus, so we alternate now, so it's sin pi/3 cos theta. Now, so therefore cos theta, now cos pi/3, because cos 60 that's half, so it's half sin theta. Minus here, sin pi/3, that's sin 60. What's this sin 60? Sin 60 is √3/2 cos theta. So we can group the cos theta terms. Let's group. If we group the cos theta, we'll end up with cos theta plus √3/2 cos theta is equal to half sin theta. I imagine we can times both sides by 2. If I times the left hand side by 2, I end up with 2 cos theta, just to get rid of the fraction, plus √3 cos theta equals sin theta. So what else? We can factor out cos theta. The factor out cos theta would have 2 plus √3 in the bracket equal to sin theta. I guess we can divide both sides by cos theta. Let's divide both sides by cos theta. If we divide both sides by cos theta, we'll end up with tan theta. Sin divided by cos, that's tan, and cos theta cancels itself here. So tan theta is 2 plus √3. Tan theta is 2 plus √3. Let's calculate the value of 2 plus √3. Which means that theta now would be equal to tan inverse 3.732, which is equal to 75 degrees to the nearest whole number.